Welcome to another awesome edition of Comet Algebra. This video is for Algebra 1, Chapter 8, Section 4, Translating Power Functions. Now, graphing is a visual representation of any mathematical relation. In the past, remember, we graphed absolute value functions. They were in the shape of a V. Remember how we took that V and we slid it left, right, up, down, made it skinny and fat? Well, that's what we're going to do with the power function of y equals x squared. I would like you to have your graphing calculator ready and using it to help you try to put your guesses into it to see if you're getting these translations correct. So the first one I want you to put into your calculator is y equals x squared, and then graph it. Now, when you transfer the graph from the calculator screen to your paper, you need to graph it accurately. So you may have to go to the table and look at some values and plot some points. So I'm plotting 0, 0, 1, 1, negative 1, positive 1, and then it's 2, 1, 2, 3, 4, and then negative 2, 4, and then connect these. And this should be showing up on your calc screen. So this is the one we're starting with. So that's why we call it the parent equation. Now we're going to take this parabola and do some shifting around with it. Now what I'd like you to do is press pause on the video and enter some guesses on your calculator how you could take that parabola and make the whole thing go up 4 units. So you'd want on your calc screen, want it to look like this. It's like you took the vertex was on 0, 0, and you moved the vertex up 4 units. So take a minute, hit pause, and figure that out. So I assume you figured out that to move it up 4, you just take x squared and you add 4 to it. So the next translation is to take this parabola and move the vertex down 6 units, so that it looks something like this. So push pause on the video and enter your guesses and make this parabola move down 6 units. So I assume you ended up with x squared minus 6. Now let's look at the next translation. This one wants you to take the parabola, the parent equation, from the vertex at 0, 0 and flip the whole thing upside down so that it looks something like this. So press pause on the video and figure out what you could change to that parent equation to make the parabola upside down. All right, and I assume that you found that you just put the negative sign in front of the x squared. The next translation is to take the parent equation, the parabola, and move it to the right 3 units. Now, remember when we did the absolute value right and left, there was a funny thing going on, a funny opposite thing with if you're moving it to the right, that it may not be positive that you need. So you want your parabola to look like this, where the vertex was here at 0, 0 and it moved over here 3 units. So please press pause on the video and figure out what you can enter in your calculator, and I'll give you a hint. It involves parentheses. All right, so I hope you figured out that you have to put x minus 3 inside and the whole thing squared. And just please take note, this is a minus sign and the vertex moved to the right to a positive 3. So we need to take note of that. All right, next translation is to move the parent parabola to the left 5 units so that it looks something like this. Please forgive my lousy parabolas. Hard to draw them freehand with this stylus. So please press pause in the video and come up with the correct equation to move the parent parabola left 5 units. And I assume that you found that it is x plus 5 inside the parentheses quantity squared. The next translation I want you to try is to make the parabola thinner by 1/2 so that it looks something like this. So please press pause on the video and see how you can make the parabola half as thin. Alright, I hope you found that you just need to put a 2 in front of it, which seems weird. You would think that you would put a 1/2. But you think about it, when you put this 2 in front, it's making the y's go up twice as fast. So instead of here at 1, you double that up here at 2. Over here at 2, you're not at 4, you're at 8. So the 2 makes it go up twice as fast. So keeping that in mind, what could you do to make the parabola open wider and make it look something like this? And again, push pause on the video and see if you can figure out how to make the parabola twice as wide. Alright, and hopefully you found that by putting a 1/2 in front of it, doubled the width. Again, kind of opposite of what you'd think. So now, a vocab term, I've been using it. You need to know what a vertex is. And on a parabola, it's just the turning point. So it's the minimum value when it's like this. Here's the vertex. And if you have an upside down parabola, the vertex is a maximum value. So the general form, the general equation for a parabola is here. Y equals x minus h in parentheses quantity squared plus k, where hk is the vertex. Now you'll notice that k doesn't change signs. Whatever that is, if that's a positive k, this is a positive k. If that's a negative k, this is a negative. But notice you have a negative sign in front of this h, but not this h. So you need to kind of just take note that this h has an opposite thing going on. So h is the opposite of this negative h. And we notice that in our graphing. So k moves the parabola up and down, the number that's outside the parentheses, while h moves the parabola left and right. And remember, it's got that backwards thing. Left is the negative direction, but h does that when it's positive. Right is the positive direction, but h does that when it's negative. Now all the things that you did, all this knowledge, transfers very nicely to another power function. If we considered y equals x cubed, enter that into your calculator and graph it. And the graph would look something like this, where it's kind of curving one way below the point of inflection. It's called that instead of a vertex because it's a little different. On this side of the point of inflection, it's curved. I was trying to exaggerate it there. It's curved that way, and here it's curved the other way. So it's kind of like an S curve. And for the general form of a cubic function, it's the same thing, except the exponent is cubed, where hk is the point of inflection. I'll try to make that a little more, well, I'm kind of try a different color here. So this blue here, this is the point of inflection where it changes curve. And once again, k would take this curve, this S-shaped thing, and move it up and down, and h would move this left and right. So you can try a few with that power function. All right, so now you have the knowledge you need to do section 8.4, so have fun graphing.